Good morning, all. This is Suresh Babu, Control of Examination, Sri Shanmuga College of Engineering and Technology. So, in today's sessions, we will be discussing about the fundamental of instruction set of 8086, and we'll discuss about the data transfer instructions. So, regarding what is an instruction, what are the basics? Instruction is nothing but it is a binary pattern designed inside a microprocessor to perform a specific operation. In instructions, we'll be having two different types, two different contents. One is opcode and operand. Opcode, it is known as the operational code. It specifies the type of operation the processor has to perform. For example, if you write move x comma y, it will be converted to 08 in the case of 8086, and that is known as the opcode. Operand is nothing but on which we are to perform the operation. That is, the data is known as the operand. We will be using an 8-bit operand or 16-bit operand in case of 8086 microprocessor. And we have assembler. Assembler is nothing but it converts the instructions into a sequence of binary bits so that the bit can be easily read by our microprocessor. And mnemonics, it's a shorter form of the code what we write. Type of instructions. We almost have 9 different types of instruction set, namely data copy or data transfer, arithmetic and logical instructions, branch, loop instructions, machine control, flag manipulation, shift instruction, rotate instruction, and string instructions. So today we will be discussing about data copy or data transfer. Why we call it as data copy or data transfer means when we perform these kind of operations, the data will be actually we say we write as move. Move means actually it refers transfers, right? But actually what happens means the content present in one particular locations will be copied and stored in another location. There we can call it as either a copy or a transfer instructions. And the general format for data transfer instruction is move destination comma source. In the source, it may be immediate data, or it may be a register content, or it may refer a memory locations. In the case of destination, definitely it should be a register, or it may be a memory operand. And both source and destination cannot be a memory location, or it means that you cannot transfer one data from one memory location to another memory location directly. If you want to do so, you have to copy it to a register, and then from the register to you can write it back to the next memory location. You see here we have given an example for move bx comma ax. The actual operation performed in this instruction is the content present in the ax register will be moved to bx register. So before execution we have 2000 in ax register. Actually you have to tell it as 2000h. H means hexadecimal number. So after execution, if you look at bx register, that content present in ax will be copied to bx. Thereby this means that data copy or data transfer instructions. So two examples are given. You can see that. The next one is regarding stack pointer. So it is a 16-bit register which contains the address of the data item currently on the top of the stack. So stack pointer refers the top of the stack. Stack is nothing but a special memory location designated inside the memory of microprocessor. In the case of occurrence of interrupt or in any emergency situations, the data will be temporarily stored in the stack. Stack work on the principle of last in first out. That is, whatever is last fed to the stack memory location will come out first. So stack will work with two different operations, pushing and popping. Push the mnemonics for push is push source. So here we have to mention the source. So source can be a register, or it may be a segment register or memory location. So this instruction will push the content of specified source onto the stack. So source means it is the location where we have the data. So after execution of push AX, an example is push AX. So you see This is a stack pointer. So stack is representing the top of the stack. So after execution, we are given push cx. So cx is our source. So actually you can see what is present in ch and cl. So cl is the data present in cl is known as lower byte in data, and the data present ch is known as the upper byte data. So after executing push cx, you can see what happens. So after execution, the stack point is pointing 200h, right? So to the member location of 200h, the content of CL will be pushed, and to the next it will be auto incremented, and to 2001 the 10 will be copied. Now 10, the member location 2001 will be 2 will be the next stack pointer content. Similarly, pop is the reverse to that of push. So here the instruction format is pop destination. So here you have to mention the destination address. So it may be a register, or it may be a segment register, or it may be a member location. So an example, pop AX. So what happens, you can see now stack pointer is pointing to a new empty space. Stack pointer, first the higher byte data will be moved because it is the last data which will be moved to the stack pointer. So then the lower byte will be moved, and the stack pointer will be now auto decremented. So you can see here before execution in 200h and 2001 we are having the data 50 and 30, and we are given the instruction pop bx. So pop after execution, you see in 2000 the 30 will be copied to bl and 50 will be copied to ph. First 50 will be copied and the stack will be auto decremented, and the next data from 2000 will be copied to the stack memory location. Now the stack will be having one value less than 2000h. Next one is exchange. Exchange is instruction used to exchange data between two different locations, and the two different locations cannot be a memory location. It can be one may be a register and another memory location, or both can be a register. So in exchange, if you give exchange bx comma ax, the data from ax will move to bx and the bx will be moved to ax. So directly the movement cannot be possible. Either the content from ax will temporarily move to a temporary register, and the bx will be copied to ax, and from the temporary register to bx. So that is designated here. Then when you want to communicate with the externally connected devices, you can use two different instructions, in and out. In is used to read data from a specified port address. So here to specify the address, you will be using dx register. Dx register will be having the port address. So in AL, 80H means the 80H is the port address. So the data from port address will be copied to AL register. Or you can give in AX, DX. Now DX represents the 16-bit port address. So it's an example. You can go through that. The next one is out. Similar to that of in, if you want to transfer the data to the port address, you can utilize the instruction out. So out address comma AL register or AX register. 16-bit operation means you have to use AX, 8-bit means you have to use AL. So to transfer or to perform and communication with externally connected ports, you can use only AL or AX register. And the next one is about LEA, load effective address. So it loads the effective address formed by the destination into the source register. So you can see LEA BX comma address. So the address will be copied to BX register. The next one is LDS, load data segment or extra segment along with the address specified here. So what happens means the data present in the address specified in the instructions will be moved to the source destination registers specified, and the data present in the next two memory locations will be copied to either to the data segment register or to the extra segment register. So LDS means it will be copied to DS register, data segment register. LES means it will be copied to extra segment register. Next one is LAHF. This instruction loads the content of AH register from the content of lower bit of the flag register. So you all know that 8086 supports the 16-bit flag. So the lower bit of that is a bit number from 0 to 7 will be copied to AH register. Similarly, store the content of AH register will be stored to the lower byte of flag register. Then last two instructions is push and pop. Push means the instruction decrements the stack pointer by 2. It copies the content of flag register to the member location pointed by stack pointer. Similarly, pop F refers copying data from the stack pointer track segment register to the flag register.